January the 18th, 2026. Guys, we have some new information. We have the new images coming in from the X-flare this morning. Now, they have noted that there's a sizable CME that's approaching, but it has not been put on the models. We're going to take a look at that. But what you're looking at here, and this is one of the coronagraphs from GOES 19, is two things. One, this is the sun in the white circle, guys, and this is what's called an occulter disk. Blocks out the glare so you can see what's around it. The main body has come to the left, right there. But what's called a halo CME, which is a full rounded blast, and it's coming towards our planet, that's what these outer ring right there, see that? That's called a halo CME, coronal mass ejection. And the left side really took a lick. Now, we need to hurry up, and I hope they hurry up and get us the CME model so that we can look at the arrival times and dates and where it's going to impact at most. But these are amazing images. Look at that. Before that happens, that's what you're looking at is kind of the normal coronagraph of the sun, and then bam, very large explosion. And what they're talking about, again, is a strong X 1.9 flare. It first came up, and before it had peaked and started going back down as a 1.7, then a 1.8, then it's saying here 1.9, but the chart is actually showing it as an X 1.95, almost an X2 flare. But it says this flare was observed around 4341, that's the sunspot, on Sunday, January 18th at 1808 UTC, and was associated with a type 2 radio emission, along with a 10 centimeter radio burst called a 10 flare, lasting 2 hours, guys, 122 minutes, and measuring 3,200 solar flux units, or SFU, and a noteworthy coronal mass ejection is associated and contains a full halo signature. That's what we opened the video with. It says, it appears, the main bulk of plasma is headed just to the east. However, with the halo present, an Earth-directed component is almost for certain with an impact likely within 24 to 48 hours. I would expect a geomagnetic storm watch at least a strong G3 threshold to be issued once a tracking model is issued by NOAA. Now, we're dealing with X-ray flux, and that's what an X-flare, that's where it gets its name. And you're looking at 3 days here, and this is the one today. And that's why they're saying that blackout was 122 minutes. Look at how long the flare, or the duration of the flare, was. Check this out. It's still coming back down now. It's still having its effect, and then within 24 to 48 hours, we're going to see the coronal mass ejection and its impact. But that is what's called a long duration flare. And 122 minutes is a long time. But now, again, 1.95 for the flare. Now, this image came in from stereo A. We don't see a whole lot of that anymore. It's really way past its date, and the images are grainy from so many years of bombardment by solar flares and CMEs and energized particles. But look at this explosion. The sun's in the center. Again, you've got an occulter disk, but the white circle is the size of the sun, which is huge. And look at this. Look at that explosion. And you can see how this is part of the halo if you look at it very closely through this area here. And they were talking about the brunt was thrown out to the left. That's a good thing, but I want to definitely, like I said, see those trackers, because the satellites that are picking that energy moving towards our planet up, they will give us the speed, temperatures, things like that, and that will help us. Now, LASCO is one of the satellites also that gives us an Earth-facing perspective. This is the C3 camera. It's the widest one. They call it the blue one. The red one's real tight. You're looking at 3 planets. I think the one on the left would be Venus. Mercury is here, and Mars is off in the distance right there. But what they do not have, guys, is the last few frames. I wanted to show you this because it's amazing images, but it cuts off right before, notice the timestamp here, on the 18th, right before that explosion. And each satellite director, or whatever company, whether it's NASA or NOAA or maybe the European Space Association, ESA, they process this at different times, and the satellite has to beam it back to Earth, and they have to go in, put it into a format that we can deal with, and then upload it. So this one has not been updated yet, but should be some pretty spectacular images from this view. And cuts off right before the flare. Now, this morning we were looking at a different image. This is actually three different cameras. There's 12 aboard another satellite called the Solar Dynamics Observatory. Also gives us Earth-facing perspectives. What it did not show was the full size of this coronal opening. You could see it was up here. It was like the head of a horse or something like that here, a dog. But in here, as the Earth is rotating from left to right, this is a very wide opening here. And that, again, it's just going to let the solar wind continue to increase and last for several days. And that's not counting the impact of this explosion right there. And I mentioned this in the earlier video. And guys, we did this maybe a month ago when this sunspot group was on this side of the sun. It takes about 27 days for a full rotation. Sometimes they fade out before they get around. Sometimes they maintain the size. Sometimes they're stronger. But this Earth connectivity or Sun-Earth connectivity map, guys, is very important. Now, this is Mars here. The orange circle, this is where the Earth's plasma tube that attaches to the sun and extends all the way to the Earth. Same thing with the one from Mars. And 1431 or 14341 is the sunspot right here that threw us this X 1.95 solar flare this morning, right there. And that's what I said, as this thing starts to move, and this will change. It's like a rope almost. If you're in there, I guess the best way to describe it is each planet has a connectivity point, and they're like ropes that go out, tethering everything to the sun. But every 8.2 seconds, the speed of light through this tube, which is larger than our planet, it completely encapsulates us. And the Earth is not anywhere as big as this spot here. That's what I'm saying. It comes in, and we have a fleet of satellites that fly in through this and pick it up. But it's delivering energy to our planet every 8.2 minutes. And I think there's some transfer back and forth. Anyway, very important. It's cool to know it, but what happens is there's a lot of energy involved. So as these sunspots rotate around, and this is dancing around here, they come into contact. And that's what I warned about the last series, and that's exactly what happened. We got that X flare from there. Let's step this through a few days. I've got it for today. This is the update of the actual location right now as of 3:56, say 4 p.m. Central. We're going to move it forward. You see both of these drifting somewhat. The sun's, and it doesn't go out very far. But that direction, see it right there? This is going to cross right on top of the Earth's connectivity point. That's going to be the most dangerous spot. But what we're seeing now, the activity is already dangerous. But I like to talk about this because it's a whole different video, and I have done videos about that plasma tube and how it's like a long, wavy. It's invisible. The satellites pick up the energy, but they call it a plasma tube, and it's just long and wavy and comes down, encapsulates Earth, and it's like the umbilical cord to our planet. It's crazy, but that's what's going on. So we're going to have to watch 14341 as it continues to advance toward what I call the ignition point, because you've got two different magnetic configurations, and that's why we're getting the X flares. And you're going to add a lot of different configurations when you hit this plasma tube. Again, we're watching it, guys. As soon as I get the info on the CME trackers, I'll let you know, and we'll know some timing and impact areas. It's a heads up. Be safe.